Hello, in this lesson we're going to use properties of isosceles and equilateral triangles. Some vocabulary we're going to come across are legs of an isosceles triangle, the vertex angle, and base angles. We start here with an isosceles triangle. An isosceles triangle has two equal sides. Those two equal sides we call the legs. The side that isn't the same, that's different, is called the base. In an isosceles triangle, the two angles opposite the bases are called opposite the legs are congruent, and they're called base angles. They're on the base. That's why they're called base angles. The one that's different is the vertex angle. And that's what the first theorem relates to, that says, hey, if you have an isosceles triangle, in other words, if two sides are congruent, then we know the base angles are congruent. The angles opposite those sides are congruent. The converse of the isosceles triangle theorem says just the opposite. It says, hey, if you have two equal angles, then you know the triangle is isosceles, so it has two equal legs. We can show that proof right here. We have this triangle, and we can draw in an auxiliary line, LN, and I'm going to make LN the midpoint of that side. So in other words, I know MN is congruent to NP. Because it's isosceles, I know LM is congruent to LP. And notice LN is in both triangles, so LN is congruent to itself by reflexive property. Then we can say the two triangles are congruent by side, side, side. And therefore, angle M is congruent to angle P by CP, CT, C. So now let's apply that to a problem here. I want to name the two unmarked congruent angles and sides. I'm going to start with triangle BCD. So I'm going to look at triangle BCD here. Well, look in BCD, angle C is congruent to angle D. Therefore, I look at the sides opposite those angles. And that tells me side CB is congruent to side DB. So I'm going to say side BC is congruent to side BD. Now look at the bottom triangle. I'm told the two sides are congruent, so by the isosceles triangle theorem, the two angles opposite those sides are congruent. So in other words, angle A, which is opposite BC, is congruent to angle BCA, which is opposite side AB. So I can say angle A is congruent to angle BCA. Because we know the opposite angles are congruent. Now, some corollaries that follow directly from our isosceles triangle theorem is this, that, hey, if you have an equilateral triangle, then we know it's equiangular. Because if two sides are congruent, I know the base angles are congruent. Well, in this case, I have three sides congruent, so all three angles are congruent. And then more specifically, since all three angles are congruent, and I know that by the triangle angle sum theorem, they add to 180 degrees, each angle of an equilateral triangle is going to be 60 degrees.